Welcome, everyone. My name, I guess I'll introduce myself in a bit. My talk today is called Poetry, Dependency Management and Packaging Made Easy. If you've gone to the Poetry code base, you'll probably notice that I just completely plagiarized the tagline of the code base itself. So go there, and it's pretty self-explanatory. Today, I'm going to tell you a brief story about how I found my way to the world of poetry. Then I'll go over some jargon, because we all need that. Then a bit of history of dependency management and packaging. Finally, I'll show you some features of poetry, and through slides, show some examples. If there's some extra time, I'm going to do my best and try to do some live examples of poetry with all the dragons and dangers that entail in a live demo. And then hopefully maybe a bit of time for questions either afterwards or at the end. So my name is Samuel Roeca. That's my Git picture. My name is Papa Sam on GitHub. I'm one of those unfortunate people whose Xbox Live username has followed them longer than it should have. I'm a happy user of Linux. I love to tinker, so much in fact that I spend most of my time in Vim, and I think some of you should too. I run the New York City Vim meetup, trying to build a community around this lovely editor. I'm also the head of engineering at a digital marketing agency called Kepler Group. We're a full services agency helping Fortune 500 clients serve their marketing across the digital ecosystem. And I also run an engineering team of about 20 developers. We're building some really cool internal code bases to help differentiate us in the marketplace. And that's also a picture of me back home with a colleague. We wrote Kepler, Hawaii in the sand. I'm originally from Hawaii, so if I seem a bit off, maybe that's why. I don't know. They're all normal, so maybe it's just me. Cool. So some examples of Python that I've written and deployed to GitHub and PyPa and all that. Back in 2016, I wrote a library called LaTeX Build. This helped me sort of templatize LaTeX documents for a project I was working on with other people. It uses setuptools, which I'll cover in a bit. And then fast forward to 2019, there was a dark period where I didn't do much. I wrote a library called TOML sort that currently has, I think, 3 stars, 2 of which are my colleagues. But it's on PyPa, and it sorts your TOML files. The next closest competitor has 4 stars, I think, so the TOML sorting problem isn't very popular yet, but it's coming. Then I wrote my own language server called Jedi Language Server. It was just a test project, and there's a more famous language server called PyLS or something like that. But I just tried to write my own. And then finally, this presentation is written in a framework called Hovercraft and deployed or run with poetry. So the 3 projects at the end use poetry. The first one uses setuptools, and I'll talk about how I made that transition. So here's story time. We had a problem at my company. In late October 2018, some users reached out to us and said, we can't get into the application. We're like, what happened? We didn't change any code, but people were logging in and then immediately being redirected to the authentication microservice. And this was a problem. It wasn't a security problem because nobody could get in, but it was still a problem. So we really racked our brains and we looked at our requirements.txt, and it looks kind of like this. This is just an example, no real code here. But we had Flask version 1, Jinja 2 version 2. And then we were like, okay, well, maybe we got to dig deeper. And so we went to Flask and sort of read its source code and saw that it had these version constraints. And we're kind of looking around here and, okay, that might be something to look at. It's called itsdangerous. We're like, maybe that's where the problem lies. And it turns out itsdangerous had just reached version 1.0. This is hilarious. It's dangerous. It's great. The default algorithm for signing cookies had changed. And so people logged in. So all we'd done is redeploy our authorization microservice. We hadn't changed any code. But because a dependency of a dependency had changed, the latest version was installed, and the signing algorithm differed between our microservice and the rest of our services, which were using a different algorithm, and nobody could get in. And that was a really fun journey. It was a great way for an organization and an individual to discover the importance of dependency management. And we considered a lot of alternatives at this time and ended up settling on Poetry, which had just come out recently. So again, hopefully the remainder of this talk is about poetry, and hopefully you'll come to a similar conclusion that I have. The author of Poetry's name is Sébastien. I don't know how to pronounce his last name. He hasn't told me, so Sébastien it is. And his GitHub name is sdispatter, so you may have seen him on such projects as TomlKit, Poetry. He wrote a library called Clio. I did not write Poetry. I've submitted some issues that were, I've participated in the discussion, but I have not written this library. I'm not claiming to have written it. I'm just a huge fan. Jargon. I'm going to use a lot of words. Let's figure out what they mean. Python, this is standard Python terminology. We have a module, and when I say module, I mean a file that contains Python code. Most likely ends in .py. That is a Python module. A package, in the context of Python and in the context of this talk, is a directory of Python modules. So as you can see this area, we have my package with 2 modules inside of it. Finally, a distribution is an archived module or package. Can be in tar format, can be in zip format. Think of it, you take all your assets and just mush them up into one thing, and you can send it out into the universe. That would be an example of a distribution. Cool. So when I use those words, that's what I mean. Dependency management. Now, this isn't quite as well defined in the Python community, so I'll use Wikipedia's definition. It's the process of installing, upgrading, configuring, and removing, insert my own, Python distributions used by your project in a consistent manner. So my project depends on mushmash tar files living in PyPi. Those would be my dependencies. Managing those dependencies for my project would be dependency management. Cool? Packaging. This is a new concept. It's the process of creating and uploading a Python distribution to be used by yourself and others. So taking my code, mushing it into a distribution intended for distribution. That would be packaging, sort of like this person giving a package to the other one. I can't quite tell who's giving to who, but it's being transferred. All right, a little bit of history. So these words, packaging and dependency management, haven't been very separated in the Python community historically. And we'll kind of maybe see why. I refer to these periods in 3. We have antiquity, Middle Ages, and whatever, modernity. But in the period of antiquity, from 1990 to about 2008, we had a lot of stuff happening. In 1990, I think we probably packaged and distributed things through floppy disks or other techniques. I'd have to ask Guido. And this tool process called disutils came out in 2000. It's still around in the standard library. PyPi was created. It was just an index in 2003. And I got a lot of these facts from a guy named Dustin Ingram's talk called Inside the Cheese Shop. So if you're curious about a deeper dive into some of these details, check him out. Then setuptools. The tool that I used to build LaTeX build came out in 2004. 2007, a thing called virtualenv came onto the scene. I hope we're familiar with that. It helps us sandbox our project dependencies from our operating system dependencies. Then we have pip, this tool that we all know and love. A developer who was tired of people complaining, built pip. And that's how it came to life. You can read his blog post about his feelings on that. Then we get to the Middle Ages. There was a rift between 2008 and 2011. The maintainer of pip kind of stepped away, and the Python Packaging Authority was born in 2011. And I think that was kind of, taking this period of anarchy and trying to protect ourselves from chaos. And then we got to Conda in 2012. A lot of data scientists are familiar with Conda. Pip tools, PyBuilder, 2 tools that I'm not familiar with, but I know they exist, came out around that time, so they're fairly old. The wheel format, this is just a way to package code, came out in 2013. Then we had semantic versioning, then we have PyPa standards. A lot of stuff is happening in the Middle Ages. But I think we really reached the period of modernity around 2016 when we're starting to formalize some of these standards in a way that is not too tool specific, gives us a lot of flexibility. This pyproject.toml, along with independent builds, were proposed in PEPs 5.17 and 5.18, and this just kind of blew the roof off. Anything was possible at this point. So 2017, kind of unrelated to those first two sections, Pipenv was created. We're probably familiar with Pipenv. It's a tool that is on the official tutorial of the Python Packaging Authority. I won't go into too much detail about Pipenv. This is a politically charged topic these days, so I'm not going to touch it. I'm just going to talk about poetry. I just love poetry. Give it a chance. Poetry was created in 2018, right on the heels of Pipenv. Some messages were sent. Pip, there were hella changes made in 2019. And by hella changes, let me see, I got the statistic. I did a git hist. There were 10 releases through August 25th, 2019. In 2019, 6 in 2018, and 0 in 2017. So Pip, when I say hella changes, I mean hella changes. And I guess it's PyGotham. Oh, man. PyGotham today. So here we are. So here's poetry in comparison to the rest of the ecosystem. And this is not to say that poetry is the only tool that can do both dependency management and packaging. I am simply arguing that it's the only tool that does them both really, really well. On the left, we have setuptools, twine, setup configuration, manifest. I guess it's, yeah, your left. On this side, we have tools that we're familiar with. You have requirements.txt, pip, pipenv, pipfile, poetry sitting smack in the middle. That's that. So as I've already pointed out, poetry is feature rich. It does a lot. Don't read all this, just know that there's a lot of things that it does. It adds things, it removes them, it publishes them. Poetry also exposes a familiar interface, and this is the reason I was attracted to it at first. I've been experimenting a lot with other languages. I really like Rust. It's got a cool package manager, dependency manager called Cargo, and I guess the creator of Poetry liked Rust as well because they resemble each other a bit. And he says that. He's basically like, it's a good interface. We should stick with it. And similarly, Yarn, a couple things missing by default, but we have the ability to add packages, the ability to publish them, to upgrade, a familiar interface. And there was a talk, the keynote yesterday, attracting people from other communities, trying to build an easier community to contribute to. I think similarities to tools across the programming ecosystem is important. So dependency management. I label this a walk in the park because this is a problem that's being solved by a lot of tools. I'm trivializing the problem. It's harder than I'm making it sound. But we've got Pipenv. So here's an example with the PyPa tutorial. In order to manage dependencies with Pipenv, we run this command. We then install our dependency, install a development dependency, and look, we have our dependencies managed. Let's not go into too much detail about how that works. Just side by side with poetry. You initialize poetry, you add Flask, you add Pylint, you get something similar. The point is, multiple tools solve this problem. Dependency management is a problem that is currently being solved in many places. But, dependency management is not the only problem. Let's think about packaging, or taking our distribution, sending it somewhere, making it available to others. This is a little more daunting, at least to me, when I was exploring tools in the Python ecosystem. So let's do a warm-up. We're going to use a distributed package. We're not going to build one. We're just going to use it. That's all you have to do. Pip install, and we're done. Hooray! All right, now for the real challenge. Let's make a distributable package. Okay, that's fine. I'm sure there's plenty of things I need to do, and oh my God, I have to think about all these things. I need to do project scaffolding, manage the version, control who can publish versions. I'm probably not even thinking about everything. There's a lot here, don't read it all. So let's go, I go to the Python Packaging Authority official tutorial for how to package Python code. Step 1, manually create your project structure. All right, I'll do that. follow the tutorial. Step 2, manually write a setup.py. Kind of looks like this. This is one of the simplest versions of setup.py you'll see, with all the simplicity of a Turing-complete configuration language. Step 3, build distribution with setup tools. So we get these tools. They might already be installed. I'm just adding this here to make it seem more complex, serve my argument. So Python, you execute setup.py with 2 arguments, and then in the distribution folder, we have these guys. Like, OK, I feel like I've done stuff. Now we'll use that tool twine to upload it. So we got to get a new tool, and we'll upload the dist with the star. It does something, and then it uploads to PyPI. And then, of course, after I've done all this, I'm like, well, there's a billion tools that I just looked at. Time to study. So you get in a study group, study all these different tools, spend a couple weekends on it, and then you take the blue pill. You're like, you know what? I published LaTeX build. That's enough. I'll take 3 years off. And that's what most developers find themselves in. Now let's cover the packaging tutorial with poetry. Hey! We wrote a package. OK, I'll break it down for you. Step 1, project scaffolding. We don't have a structure. Now, Poetry knew my package. We do have a structure. Poetry comes with project scaffolding as part of the project, much like Rust's cargo. This is great. Step 2, dependency management, that whole project that's a walk in the park. Now, we'll add a dependency, and it'll install the dependency along with all of its sub-dependencies, and it locks it. I'll get into lock files later. Edit software. So at the end of the day, we're still going to have to edit our software. Poetry doesn't do that for us yet. But I think with some artificial intelligence, machine learning algorithms, we might, who knows. We'll edit the stuff, and we'll use requests. Finally, we'll build our distribution. It builds. And we'll publish our distribution. We'll share it with the world. Publishes to PyPI. But if you have a private package index that you want to share it with as well, totally works. That's how we distribute things to ourselves at my company. So that's it. That's the steps broken down. What I want to go through now is a bit deeper dive into dependency management. Because what I showed before was setup.py. I kind of made a joke about it. But this is the form of dependency management with poetry. When you think about your project, you have some metadata associated with it. Again, this is in the pyproject.toml, which is a Python PEP product. And we have tool.poetry, along with your project name, its version. Obviously, it's a great project. And then the version of Python that your project is supposed to run on. So that's kind of cool. It's baked into the expression itself. We also have dependencies that are required for your project to run. So in this case, Flask. It's not the same example that I showed before. That was requests. Down here, we have development dependencies, or things that I need while I actually develop the project. Things like Pylint. I don't want to install those when I deploy whatever I'm using here to a server. I just want to have these dependencies when I develop. And down at the bottom, we have tool.poetry.scripts, which gives me, and we can get into this later, but this is really cool. And none of this is terribly different from a super well-written setup.py, but it's structured. It's easy to read. Semantic versioning. Ranges, like Node.js. So if you've worked with package.json, you become familiar with syntax like patch releases. You get a little tilde, a little squiggly line. Minor release ranges, get a little caret. For those of you who aren't familiar with semantic versioning, it breaks down a project's version into 3 numbers separated by dots. First number in 8, 10, 9, 10 would be 8. That represents the major version. If you're going to make a breaking change to your library, you will bump the major version because your users will probably be sad if they change versions. Version 9 would be a minor version. So if you're making updates that aren't breaking, you'll bump that, features. And patch releases are for bug fixes. So something's wrong, I'll bump the patch. All of these are backwards compatible. And this came out in PEP 440, sometime in the history of Python. And in Python, we don't really support these semantic ranges by default. The Python standard uses these symbols. So Poetry gives you some nice, syntactic sugar to work with them. We also lock our dependencies. So remember I mentioned dependencies of dependencies. Poetry has this poetry.lock file, which specifies the exact version of a dependency that's been installed for an application. That's important. We no longer get hit by the itsdangerous situation, even if we're not explicitly referencing the version in our pyproject.toml. So it does all sorts of cool things. It locks your dependencies, handles dependency management, enables you to build a package in a trivial amount of time. So at the end of the day, why use Poetry? And I thought I'd leave it up to Joseph Brodsky. He said, poetry amounts to arranging words with the greatest specific gravity in the most effective and externally inevitable sequence. He was talking about poetry itself, and which, this kind of translates well to the project, because I think poetry has a slick, familiar interface that makes developing Python packages and applications easy. And that's great. Poetry is not perfect. It's still being perfected. I think of this as kind of, this is the environment before something like Poetry. We had the penny farthing. And now we have this bicycle. It's not a perfect bicycle by any means. It could always be a better bicycle. We may have a slightly different design. It might be called something else. But I think Poetry resembles that thing that we need to get to, a tool that bridges the gap between applications and libraries, makes dependency management and packaging easy, and makes everyone want to hop on board. So please join us in the land of poetry. And what I'll try to do, I think I have a little bit of time, is show a quick example in my terminal of how to actually quickly make a Python package. So we'll just do poetry, new, my package. Hooray! It made the stuff. Now we'll go ahead and add requests. Oh, it created a virtual environment. That's nice. And a lot of these features aren't terribly different from Pipenv. I'm not trying to differentiate the tools right now. We could just argue ad nauseum about dependency management. But what it does do pretty well, we'll just go ahead and be like import requests, print hello. Whatever, we'll just do x equals 1. And then we're going to build the package. Oh my God. We have a wheel. It's all there. And you know what? Screw it. You know what PyPa needs right now? It needs my package. Poetry. Publish. Here you go, PyPa. No, I won't do that. We can't be bad members of the community. That would be polluting PyPa, and that's something we have to think about. Does Poetry make packaging too easy? But that's a great problem to have. So hopefully we all want to use Poetry now because I think it's awesome. And that's all for my content. Thank you very much for listening.